This video is for those of you that are doing hypothesis testing for proportions. So you in your study took one sample of some sort or did an experiment with one group, and you're looking at the percent of something that is coming out of that group. So I'm going to walk you through a couple of different examples. This video is going to be a little more lengthy because this has the bulk of everything that's going to give you mathematical support for what you're trying to prove. This is probably the most important piece of your analysis. So I'm going to start with Xenon here. He did an investigation. He wanted to see if the students at his school preferred name brand potato chips over generic potato chips. So he randomly selected 50 students from his school and had them try both of the chips in a random order. And overall, 34 of the 50 students that he sampled did prefer the name brand chips. So what I want to do from the very beginning is I want to kind of assume that there is no preference here. If there was no preference in these potato chips, what I should get as my sample is 50% of people liking the name brand, okay? Because if you have 50% liking the name brand, then you also have, I'm going to call it Q, 50% of the people not liking the name brand or liking the generic, and that is equal. And that equal percentage for both would show me that there is no preference at all for one chip or the other, okay? So P is a success. That's what I'm looking for. That's the people that like the name brand. And Q is considered a failure because that's not what I'm looking for. Now, if we assume there is no preference, and I looked at a normal curve for that particular situation, then this normal curve would have a p that was equal to 0.5 in the center. That is the true proportion of all students who like name brand chips. Okay. And if I'm assuming this to be true, and I do my study, and I get a percentage of my own, we kind of try to see where that fits on this normal curve. So what I got in my sample, we'll call it p hat because it is from a sample and not the true proportion. I got 34 students in my sample out of 50 that liked that name brand potato chip. And when I do 34 divided by 50, it gives me 68% who preferred the name brand. I could also look at Q hat, which is the percent of failures in my study. If I subtract the 34 kids out of the 50, that's going to leave me with 16 kids in this study who did not prefer the name brand potato chip. And that gives me the other part of 100%, which would be 32%. Okay, so these are the results that I got. So two things could happen here. Either 68% is just random variability because we're never going to get the same result. If we took another sample, we would get a different answer. Is that 68% really close to 50%? It's really not that different. It's still in the highest part of this curve where we typically have a large number of results there. Or is that p hat really far away from 50% in this really uncommon region of the normal curve? And if it's a really uncommon result, then we could show that we think there's actually a preference for these chips. And what that's going to depend on is the standard deviation of this normal curve and how far that's going to take it out. Okay. Now, to figure that out, we're going to run a test that's going to tell us if this result is an unusual result for us. And that is a hypothesis test or a significance test. We're going to have 4 steps to this hypothesis test. You can read those there. I'm going to work through each one of them with you, starting with step number 1, where we're going to form our hypothesis. Your hypothesis has 2 parts. It has a null hypothesis, which is represented by H naught or H sub 0. And this null hypothesis is always going to be what we assume to be true from the very beginning of the study. Before we ever even took a sample, before we even got results, What did we assume from the very beginning? Your alternative hypothesis, which is represented by H sub A, is always going to be what we are trying to prove. And what we are trying to prove should be based off of the result that we got. Okay. Now, this alternative hypothesis could be one-sided or it could be two-sided. So if you are trying to improve or trying to prove that something increased, then we would want to use a greater than for our alternative hypothesis. If you are trying to prove that something has decreased, then you would want to use less than for your alternative hypothesis. And if it is a two-sided alternative hypothesis, then you really don't care if it has increased or decreased. You just want to see if it is different. It could have gone down, it could have gone up, but you just want to know if it's different. And in that case, we're just going to use a not equals for the alternative hypothesis. Now note that both of these must be based on the parameter that you are interested in. That is the population value of whatever it is you're trying to compute. And in this case, we are looking at proportions. So these hypotheses should always be based on P, the true proportion. So for Zenon's project, where we're looking at the true proportion of those who preferred name brand, his hypothesis will be this. The null hypothesis is that that true proportion that I'm looking for is equal to 50%. Because before I ever took my sample, I assumed that there was no preference in potato chips. It was going to be a 50-50% type situation. So his null hypothesis should use the exact same values. It should still be P and it should still be 0.5. But we need to look back at what we got for our results and try to figure out what we wanted to prove. Did we want to prove that it was going to be different overall? Were we looking for a preference for name brand or a preference for generic? Or were we just looking for a preference for one? And we were just looking for a preference for name brand potato chips. And we got the result of 68%, which I feel like is quite a bit higher than 50%. So what I want to do with this result is I want to try to prove that this is actually bigger than 50% and I actually have a preference for name brand potato chips. Okay, now once you've set up your hypothesis, you're going to have to do some condition checks. So condition check number 1 is your study had to be random. And you're just going to verify that by however you chose this. Did you do a simple random sample? Did you randomly assign treatments in an experimental study? But just verify that you have included randomization in some way, some fashion. Your second condition that you must meet is called your success failure condition. Your success failure condition for proportions is that NP hat has to be greater than or equal to 10, and your NQ hat has to be greater than or equal to 10. And we can do this two ways. N is the size of your sample, which is 50%. P is the proportion of successes. We had 68% of students that like those chips. Combined, when we do the multiplication, it should just give me the number of successes. And we already knew that in our study. They told me that from the get-go. If you do that multiplication, you're going to get 34. So we had 34 students total that preferred the name brand that is greater than or equal to 10. And we had, you can do 50 times 0.32 if you want to, but I already know the number of students who did not prefer it. That was 16. And that number is also greater than or equal to 10. So this condition has checked out. And condition number 3 is called the 10% condition. And for the 10% condition, we're just going to take the sample size and multiply it by 10. My sample size is 50. When I multiply that by 10, I get 500. And 500 is going to be compared to your population. Okay. This value right here, you have to have more than 500 for your population. So basically, this number right here has to be less than your population. And for this result, I would assume that I do have more than 500 students in this school, and this condition would check out. Now, this is not particularly something that you need to include in your PowerPoint when you do your final presentation. You could make a small statement that you checked your conditions for the testing, they all met. Don't necessarily have to run through how you did each one of those condition checks. It is something that you would probably want to include in a final report if you have to turn that in. But as far as your presentation, you can just kind of say you checked them, they worked, and move on. So all of my conditions check out. Obviously, if your conditions don't check out, you're probably still going to want to run your test anyway. We have to grade you on something. You would just probably want to make a general statement at the end of your results that these may be unreliable because this condition didn't check out. All right, so the third step is actually running the test, and you can do this in your calculator. There are some formulas that you could use as well if you took AP Stats this year and actually worked through those formulas and you would rather use those, and you absolutely can. For those of you that just had Intro to Stats your junior year, it's probably going to be easier for you just to use your calculator because you didn't have time to go through all of those formulas. So give my computer just a second to crank this calculator up. And your test for statistics is going to be under Stat. And you're going to use the right arrow to highlight test. You're going to choose number 5 for one proportion z-test. And it's going to ask you some questions. So the first one is P naught. That is your null hypothesis, what you had from the very beginning. So we were assuming that it was 50%, 0.5. Your X is the number of successes that you had in your study. So for this one, 34 students preferred the name brand potato chip. The N is your sample size. For this study, that was 50. And your proportion is the alternative hypothesis that you chose. Now, just kind of ignore the P naught in the back. That's a little confusing to some people. You literally just want to choose the answer that looks exactly like you set up for your alternative. We chose greater than for our alternative because we were trying to prove that it was bigger than 50. You can choose whatever color is your favorite, and then you can calculate the results. Now, from this, you'll see that it gives you the sample size back. It tells you what p-hat is, which we already knew that. The only thing that I'm really interested in right here is this p-value, the one that doesn't have a hat on it. And that is not the true proportion. There's a lot of p's and it gets really confusing. But this is not the true proportion. This is the p-value that we get from the test, which tells me the percent probability that I would get the results that I am seeking. And that p-value is 0.005. If I went back to Stat, back to Test, choose number 5 again, and just run that one proportion test again, all that information is still in there, but instead of calculating, I get the calculator to draw it for me instead. You're going to notice that it gives you a curve. It looks like this. And here's what that curve is telling you. Let me get back to my big screen here. So here's what that curve is telling you. This is the curve for when P is equal to 0.5. That's what we have assumed for the very beginning with this test. And the p-value, or the probability that this is going to happen, is 0.005. It's very close to a 0% probability that I would get this result if I did not have a preference. And my result is way up here in that tail. It's a very tiny, small little probability up here that that would happen. So I am thinking that I have mathematical support that there is a true preference here. This is not a common occurrence, okay? Now, there is a statement that we want to make, and that statement is going to be based on the level of confidence that you are running this test for. I'm going to go to your final step here. So our final step is to link the p-value to a conclusion in context. If that p-value is small, and I'm going to say I'm comparing it to 0.05, I'll tell you why in just a minute. 0.05 is kind of the standard comparison. This 0.05 is called an alpha level. It looks like one of those little Jesus fishes, but it's the Greek letter alpha. And I'll tell you how to set that up in just a minute. But if that p-value is less than 0.05, which means it's small, we are going to reject the null hypothesis. And if you think about it, if I have a null hypothesis here that said the proportion is 50%, and then I have an alternative hypothesis here that was trying to prove the proportion was greater than 50%, if I reject the null hypothesis, that means I'm stating the alternative is true, okay? So that means I have evidence of the alternative, the HA, okay? Now, this is a typo right here. This is supposed to be a greater than, so let me change that. All right. If that p-value is large, if it is greater than the 0.05 that I want to compare it to, then we are going to fail to reject the null hypothesis, which means I'm not going to mark it out. And that means I do not have evidence of the alternative. Okay. Now notice both of these are written the same way. Both of them start with a statement about the null hypothesis, and both of them end with the evidence for the alternative hypothesis. Your fail to reject, always, that's a negative word, always goes with do not have evidence, which is also negative. And those are always going to be associated with the greater than. The less than is going to be the not negative one. We're rejecting it, we're not, we do have evidence, okay? So my conclusion for xenon, we always start with our p-value for our conclusion. And that p-value that we got from our test was 0.005. Since that p-value is less than the 0.05 that I want to compare it to, less than means that I'm going to reject the null hypothesis. And that means I have evidence of whatever it was I was trying to prove. And in Xenon's case, he was trying to prove that there was a preference for the name brand potato chips. So I have evidence that students prefer the name brand. Okay. Now, back to that alpha level, and that's pretty much all there is to a test. However, that significance level can change. So on this one, my confidence, or my alpha level, was 0.05. If alpha level is 0.05, the confidence level is the complement to that as far as your 100%. So your confidence level here would have been 95% or 0.95. that alpha level can change based on how confident you want to be in your answer. So if you wanted to be 99% confident instead, then that alpha level would change to 0.01. If you wanted to be 90% confidence or confident in your answer, then that alpha level would change to 0.1 or 10%. So depending on what you set as your alpha level, that's going to change the result of your conclusion. So if we're looking at Xenon study on the chips, if I change that alpha level to 0.01 and I started that conclusion based on the p-value that we got from Xenon study, 0.005, comparing that to my new alpha level, 0.005 is still less than 0.01. So we would have gotten the same result this way, even if we had changed it to a higher confidence. However, if I set that alpha level to be 0.001, that p-value now, which was 0.005, that p-value now is greater than 0.001. So in this case, I would have failed to reject the null hypothesis. And since that's negative, I do not have evidence of a preference. Okay, so now that I've explained all the steps to this test, let's run one more. Let's just do one more example. And I'm also going to compare it to what we did for confidence intervals. So you have a state's Division of Motor Vehicles, the DMV. It claims that 60% of teens pass their driving tests on the first attempt. An investigative reporter examines an SRS of the DMV records for 125 teens, and 86 of them passed the test on their first try. Is this good evidence that the DMV's claim is incorrect? And you would like to be 98% confident. So if I'm 98% confident, that means I want to carry out this test at the 0.02 significance level. All right, so I am going to run this test. Even though I haven't separated it out, you have to do all the steps. So we're going to set up a hypothesis where my null hypothesis is going to focus on the parameter of interest, which is the proportion of all teens that pass this test. And what we believe to be true from the very beginning is this DMV claim. They have claimed that 60%, 0.60, passed the driving test on the first attempt. What I want to do is I want to try to prove that this has changed in some sort of way. Okay. Now, 86% of them passed the test on their first try. I'm not, even though I could get a p-hat for that, I'm not really sure that I care if it's greater than or less than. It's not like the preference thing where we had to have a greater than to show that they preferred. We just want to prove the DMV wrong. That's all we want to do. We just want to prove that it is different from 60%. So my alternative hypothesis is that I don't believe it to be 60%. I think it's different. So I'm going to try to prove that it is different by setting up an alternative hypothesis of not equal to. Okay. Now I'm going to see what I got from my result. 86 from my sample out of 125 in that sample passed that test the very first time. If you divide 86 by 125, you get a percentage of 0.688. I could also look at the Q hat here. So if I do 125 minus 86, that leaves 39 people in that set who did not pass the test on the first try, which is going to give you a percentage of 0.312. Okay, so it does look like I got a higher result. It's not a lot higher. It's 68 where they claimed it was 60. So this could be just random variability. It could depending on the standard deviation, it could be way above the mean. So we're going to run this test to help us figure that out. First, let's check the conditions. No sense in wasting time on my test if I can't meet the conditions. So number one condition, it must be random. And it's stated here in the problem that we have an SRS. Number two, we have to meet the success failure condition. So I have to have n times p hat greater than or equal to 10. You could do 125 times 0.688, but we already know the number that passed, and that was 86. That is greater than or equal to 10. We also need to know the number that failed. That also has to be greater than or equal to 10. And we know that already too. That was 39. So that condition checks out. And then for condition check number 3, we need to meet the 10% condition, where I'm going to take my sample size and multiply it by 10. So if my sample size was 125 and we multiply that by 10, we get 1,250, which has to be less than the population. And I would assume that we have had more than 1,250 kids take this driving test. So that condition checks out as well. So I'm going to run a one proportion z-test in the calculator. So I'm going to go to stat. I'm going to go to stat, and I'm going to go over to test, and I'm going to choose number 5. My null hypothesis for this problem, we assumed from the very beginning that the DMV was correct, which was 0.6. In our result, we got 86 kids that passed the test the first time out of a sample size of 125. The null hypothesis, the alternative hypothesis we chose was not equal to. I'm going to draw this first, and I get a curve like this. You'll notice that the tails this time are in both the ends because we did a two-sided, so we just wanted to see if it was different. And we're just trying to look to see where our result falls in this. Okay, so it's not all the way in the end of the tail, so that might make a difference, but let me go back to the calculator and actually run it this time. So stat, test number 5, all my information's already in there. I'm going to calculate it this time. And what I get from that test is this p-value of 0.04. So we have a p-value equal to 0.04. Now, we decided that we were carrying out this test at a 0.02 significance level. So in the end, I'm going to take the p-value, that's what I always want to start with, that p-value is equal to 0.04, and we want to compare it to the alpha level that we set up. 0.04 is greater than the 0.02 alpha level, and greater than is the inequality that is associated with my negative words. So we are going to fail to reject the null hypothesis. You must make a statement about the null hypothesis, and then you must make a statement about the alternative hypothesis. That means I do not have evidence that the proportion of students passing the test the first time. I just don't have that evidence. What that means is that 68% is falling somewhere in that more, it's not down here in the little bitty part of the curve. We actually have random variability in which that occurs sometimes, even if the true percentage is 68%. Now, the confidence interval that we did in the last video, is related to this test. They should support each other. So if you go back to your calculator and run a confidence interval in the same place, if we go to stat and over to test, the confidence interval for one proportion, remember, was down here at A. So if I run the interval in front of instead of the test, it will already carry over your information. We had 86 out of 125. We do need to change the confidence level. This one we said we wanted to do at 98%, so I am going to change that to 0.98. And we're going to calculate the confidence interval for that. Your calculator does that for you as well. And what we get is a confidence interval from 0.5, we'll just say 0.59 to 0.78. So my confidence interval goes from 0.59 to 0.78, which means we are 98% confident that this interval contains the true proportion. In context, the true proportion of teenagers who pass the test on the first try. Okay. And what that tells you is because the DMV claimed 60% in the very beginning, like I don't even need the test to say this. If I completely blocked out this test, no, that's not what I wanted to do, hang on. If I completely blocked out this test and I never ever even ran it, okay, I don't think I can block it the way I want to though, so I'm just going to X out. So just pretend I can do this though, hang on. Let's just say I never even looked at that. I just block it out for a minute. If I looked at this confidence interval, 0.59, 0.78, well, the DMV claimed from the very beginning that it was 60%. So if my confidence interval has 60% in it, then I wouldn't expect it to be different. 60%'s in there. This is what I expect it to be. I expect it to be somewhere between 0.59 and 0.78. That confidence interval is not conflicting with what their claim was in the very beginning. And if that's not conflicting, then that test should show that there is no difference, and that's what it showed. Okay. So that was the answer to part C. So that gives you all your steps for running your test. You'll need to determine what you expected from your study from the very beginning, and then determine what you're trying to prove, and then use your test and your confidence interval to give you that support.